Hello, everyone. My name is Darwin. I wanted to talk to you a little bit about some interesting ways to use GitLab Duo. Our agentic platform has had quite a few advances in how it can do code and how it can cognate with you in order to get some good code. And I want to show you an example of going from model-based systems engineering into actual embedded code. So let's get started with that. I'm just going to switch to my editor. And what we're inside of here is the Pico examples repository. You can see in the video there that I have some GitLab gateway runners attached to some Raspberry Pi Pico Ws. We're inside a working project. So recently we have deployed code to this first one in the stack, and it is blinking out the temperature every now and then. So it blinks out the 10's position and then blinks out the 1's position. And it's running at around 33, 34 degrees or something like that. So if you watch those lights, you can see it blinking out that temperature. And if we look at the serial monitor, we can see that that's exactly what's going on. So that was the last deployed successful project. One of the reasons why this is helpful is it gives the whole project a lot more context. So we have working code in this example. Our CI is worked out in order to push this to the board, and we have everything, ready to go. What we're going to do is add the model-based systems engineering capability. So I'm going to grab the relevant file here and simply copy it into the folder. This is a well-known project for SysML v2. It's a flashlight model. And if we take a look at the code here, we can see that SysML v2 is as code. So humans can understand this text file and are able to manipulate it directly. But it also renders in many different ways that system engineers find useful. So one of those ways is to render it visually. So if we view the diagram that this code makes, we can see there's an analysis block in here. And the part that's most recognizable, we get to some test data, but also this particular diagram down here of the functionality of the flashlight. And this is the main code that Duo will be able to read and start to understand how it might implement this flashlight capability. Notice this is not talking about source code. It's not talking about anything that a regular software developer would necessarily source in terms of knowing how to make a thing. This is actually the instructions on how to physically make a flashlight. What are its functions? What are the ways to cause those functions to be used? So we have this model-based systems engineering file. It's also very interesting that when it renders visually, humans are able to get the semantics of what's going on very quickly. But also because it's stored as code, AI can also understand the semantics of what's going on very quickly. So very interesting approach. What we're going to do next is we're going to look at the giving it a prompt so that we can prompt it to start making some code for us. So I'm going to grab a prompt that I have pre-engineered. And by the way, this information is also in a tutorial that we have available to you in our GitLab for Embedded DevOps self-paced course. So I'm going to grab the prompt that's relevant and drop it in. And we're going to take a look at it before we run it. So I'm going to go to my DUO Agent Platform. So I'm going to paste the prompt. And let's go to the top here. And it says, using the MBSE SysML file in this folder. And notice I don't have to tell it which one because there's only one in this case. Recode the application in that directory to follow the system's architecture in the SysML file. And then there's a few things that I've learned over other iterations that I'm inserting here. Since this is a demo and also an exercise in a workshop, we try to make sure that we're productive fairly quickly. But you can obviously tell that I've been in here working with this and finding places where it repetitively makes mistakes and putting some guardrails in against that. So we tell it to make sure it uses a certain example project in order to figure out how to monitor the button, because it's really a boot select button. So it's not the easiest button on an embedded board to monitor. We also want to make sure we have USB support so we can flash the board in the future with automation. We want heartbeat debug messages in the serial output, a startup delay, create a README that tells how the SysML maps to the model-based systems engineering. Make sure we use a version number. And then something that is interesting I keep running into is frequently it won't configure the off button or the off state to actually turn off the LED, because on a real flashlight, it's not a momentary press button. It's a slider button. So when you slide it to off, it automatically kills the power to the light. And then I tell it to simply edit the existing code files. So we're going to click enter and have GitLab DUO Agentic Chat start to figure out what it's supposed to do. We get different code every time. So if we were to do this 6 or 7 times, we'd get different code because, as you know, uh, the LLMs are not deterministic. So they don't seek the exact same end for the exact same question. So I'll just wait here as Duo does. I've given it a fairly large prompt with a lot of things to look at. I also want you to notice that we are not using an MCP server nor an API to interface with the MBSE code. We're just reading it directly. Now, because this is a small project, fairly simple as far as the functionality, but has a very thorough MBSE code example, we are able to work through the prompts without having to have an MCP server or an API interacting with the language here. However, if we had something really complicated like a SysML v2 model for an entire space vehicle or something like that, then we're probably going to need an MCP server or an API that allows us to traverse that information and have a better understanding of the different subsystems and what to look for. It's not likely you would be generating embedded code for an entire model that big anyway, but this is just sort of a proof of concept to show you what's possible. Okay, we see Duo is starting to edit some files. So we can see the diffs. Duo will create changes to your working files, but it does not commit them, which is an approach that I like because I can review the file edits for a sanity check before committing them. So it's truly more collaborative. Some systems will create commits automatically as the AI does its output, but I like this approach a little bit better. You can see now that it's moving on to the README file we asked it to create. Okay, now Duo is finishing up and giving us a summary of what was done. We'll just take a quick look at this. Actually, what I might do is commit it and get it building. And then I'll go back and we'll review. So it's telling us that it completely redesigned the architecture of the solution that we had in that directory. It did an SysML to code mapping. So it took various aspects of SysML, some of these definitions and names that were in SysML, we had asked it to directly reuse them inside the software so that we'd have an easier time mapping that. And we can see that it integrated the boot select button, which is a little bit challenging button to monitor because it's generally used to put the device into firmware mode. Retained USB support so that we can flash the device using automation, and added some monitoring and debugging to the serial output, and then created our documentation. If we look at the actual code changes, we can look in Blink C. So we can see that it added additional includes here. Actually, probably the diff is a better view. Oh, the diff is gone, sorry. So it has re-implemented this entire file. There's a lot more code than when it was simply flashing the temperature. And then it also edited our CMakes list file in order to compile correctly and have the right linked libraries. Now, I submitted it to GitLab. You should know that inside of VS Code, we can actually watch our CI tool chain, which is really helpful. A lot of embedded developers enjoy staying inside of their IDE environment, even when they're doing things in CI. So I'm going to click here. And once this job has run, we'll be able to observe the change to our actual board. Just want to point out this job right here is our security scanning job. So one of the cool things about having an AI platform that covers the entire realm of DevOps and of software delivery is that we can keep some of the things we've always been familiar with, such as security scanning, in play. And what that does is human code and AI-generated code actually have some pretty even odds of being vulnerable when generated. And so because of that, my security scanning here would catch that, whether it was a human or an AI error. Okay, it's picked up our flashing job. So that means our build ran successfully. We ran some other things on it as well. And now we've finished completing flashing it. So let's take a look at what happened. You can see now, if we wait a bit, that the board is no longer flashing. So something has changed on the code. I'm going to bring up the serial monitor, and we can see it's changed. It's no longer talking about temperature, but it's doing a heartbeat. It's got flashlight state, voltages, because there was voltages described in our systems engineering. And it says press the boot select button to toggle the flashlight. So I'm going to do that. You can see that it's off now. I'm going to touch it. And now our flashlight is on. Touch it again. And our flashlight is off. And you can see that this shows the same state changes in the actual log. Now, I'm very surprised. This is actually the first time it's done it in a single shot. If it hadn't completed it in a single shot, what I would do is grab some of the records here, especially of whatever it's not doing. Frequently in the past, I've had it where when I push the off button, the light doesn't go off. And so if I'd had that problem, I would describe here, everything seems fine, except the light does not go off. The serial monitor shows that the button press for off is detected. So you just describe exactly what you're seeing versus what you'd expected, and then paste in the serial monitor, boom, go again. And most times I was getting it in 2 shots, but this is the first time we actually got it in a single shot. So that's going from MBSE SysML v2 directly to code using a flashlight model. So that's quite a stretch. I'm going to go back to our slides and just quickly chat about a couple qualifiers to think of here. When we were working with this, it's a very simple device, and the MBSE model is actually quite thorough. So in production situations, this is frequently the opposite. Very complex device, and modelers will always decide how deeply to model something, how much detail to go into. It's pretty much assumed these days that models are processed by humans, not by AI. So perhaps as time goes forward, models will become more thorough so that we can do more interesting things like this. We started in a working code project, which from one perspective you could call a cheat. From another perspective, you could call, hey, that's pretty wise, because that means that the AI is going to have the full context of the actual embedded project that I was targeting. It produces unique code each time because AI is non-deterministic. I'm sure that if you've worked with AI, you've noticed this yourself. The prompt was pre-engineered. So if we had sat down, the first time I sat down and did this task, I would still get it in 2 to 3 shots, but over the course of many, many tries, it would have different kinds of problems with, requiring the second and or third shot. So eventually I started curating the prompt just so that we can be more productive in a demo or a classroom setting. But that's also a natural thing that you have to do with any AI task. Also, notice we had no MBSE SysML v2 MCP server or API, and that was not needed just because of the simplicity of the project and the strong context that we just mentioned that we gave it. In real-world complexity, you most likely require some sort of API interfacing to the MBSE model platform of choice and the ability to understand the semantics of that, and maybe even more strong prompting language. And then, like all general LLMs, GitLab, you can pick an LLM, but we are just sourcing a general LLM. So GitLab DUO itself does not have embedded specific training or guardrails, which is something that you could actually add over time. Thank you very much for your time and attention. If you want to see the embedded workshop and get your hands on this example and all the files to reproduce this demo, you can do so at the QR code or the URL on your screen. Thank you.